Hi guys, what we're going to do today is just cover everything that you learned in Algebra 2, and we're going to recap it to help you get a good foundation for pre-cal. Now before we even start with your notes, alright, there's the stuff that I'm about to do right here, not even on the notes, but it's good stuff to remember so when I refer to it on the notes, you know what to do, alright? One of the first things is fractions. Fractions scare everybody, but it's not as hard as you think, okay? Now, when we add, let's talk about adding first. I'm going to do something very easy. Let's say 2/3 plus, right? 4/3. We are able to add these with no problem whatsoever because they have a common denominator. Now when we add them, we'll get an improper fraction, but in pre-cal that's fine. I don't like mixed numbers, it gets confusing. But if you just add, okay, you have 2/3 plus 4/3. How many thirds do you have? All right, 6/3. Now sometimes you can reduce, in this case, it does. 6 divided by 3 is just plain old 2. All right? Let's go to a different problem, all right? What if I said 2/3 plus, I'm going to flip this number, 3/4. Now, you can't add these together because they don't have a common denominator, all right? So what we do is basically find the least common denominator, okay? And by doing that, you end up just multiplying each fraction by a fancy 1, okay? What I mean by that is, well, the least common denominator would be 12. Well, how do you make this 3/12? You multiply it by 4. But you can't just multiply the denominator by 4, you actually also have to do the top. That's what I mean by a fancy 1. 4 divided by 4. That's 1. So you're not changing the problem. What are you missing here? A 3. Now you have a common denominator of 12, but you got to multiply the top also by, in this case, 3. 3 divided by 3 is 1. 1 times anything is itself. You're not changing the problem. We're just manipulating it in order for us to simplify. All right? Now, how do you add fractions? This is another thing. Or how do you multiply fractions? You multiply your tops. You multiply your bottoms. All right? So this part first. 4 times 2 is 8. 4 times 3 is 12. Don't try to start, ooh, I can reduce this like we did up here. Well, you'll get back to 2/3 and you're back to square one. Don't do that. All right? The whole reason we're doing this is so we can add these together. So what's 3 times 3? Well, that's, oops, I was about to multiply. I am multiplying it. 3 times 3 is 9. 4 times 3 is 12. Now what happens when you add these together? They have a common denominator just like the previous one. So you can do 17. 8 plus 9 is 17. And then you just keep the bottom. You have 8/12 and 9/12. How many twelfths do you have? 17. Done. Alright. So this is the concept we need to know. Finding least common denominators. That's something we have to do. Now it's not always going to be that easy. One more thing, last thing. I'm going to make it easy because we're going to be able to get harder in a little bit. But let's just say we got y x squared plus 2 divided by x. I want you to simplify this. When I say simplify, and these are called rational expressions, basically fractions. When I want you to simplify, I want you to get them into a single rational expression. Here you have 2 of them. Here you have 2 of them. We got it to 1 rational expression. 2 of them. We need to get to 1. Well, what is this guy missing? We can't add them. They don't have the common denominator here. What do we do up here? We're able to multiply by something to get a common denominator. Well, I'm looking here, and the least common denominator would be this guy, x squared. That's convenient. So I don't have to do anything to this guy. That one I do. So when we wanted to find the least common denominator, you just multiply the top and bottom by that thing that you're missing. So in this case, Now I have x squared, just like this guy, but I gotta also multiply the top. I gotta multiply by that fancy 1. So now let's simplify this part and see if we can add stuff together and get to a single rational expression. Well, we know it's going to be y over x squared. That hasn't changed. Adding. Okay, plus. Well, 2 times x is 2x. X times x is x squared. Now you can add these together to get a single rational expression. Is it going to be nice numbers? No. You got variables. That's okay. Remember though, only combine like terms. When you add or subtract, look for like terms. Y and 2x. Not the same thing. What we've been doing this entire time is keeping the bottom, the denominator, once you find the common denominator, you just rewrite it, but then you add the tops. Well, I can't add y to 2x. They're not the same thing. They're not like terms. So, what I would rather you do, the only thing you can do, is just say y plus 2x. Now, sometimes you might see it written like this. Typically, if you have a y plus an x, they like to put the x in front. So a better way to write this is 2x plus y. Excellent. Are both answers right? Yes. Are both answers simplified? Yes. Doesn't matter which one. I just like alphabetical order. Alright, that's all we need to know, at least to get us going on this homework. Here we go. Alright guys, so the first 3 problems that we're going to be doing on the notes have to do with simplifying expressions. That's different than solving an equation. Talk about that later. Right now we're just simplifying, right? Now once again, what I said when I'm looking for simplification, either if I'm asking you to add radical expressions, I'm subtracting, multiplying, dividing, I want you to get to a single rational expression, a numerator and a denominator. That's it. Nothing fancy on top, nothing fancy on bottom, numerator, denominator, that's it. That's what I'm looking for. Alright, so right here, this looks very scary. But if I'm going to ask you to simplify, chances are, especially with fractions, something's going to cancel. Okay? But before we even start seeing if anything cancels, I'm looking at all these things that are squared. These are all quadratic expressions that we can try to see if it can be factored. I know how much we hate factoring. I'm not going to get into too much detail right now because y'all know the box method. I'm going to say, hey, when you do the box method, this is what you get. If you have any questions about that, you're more than welcome to message me on Remind. You can talk to me at the beginning or during class or after school. But for the sake of time, I'm going to do this. If there is one problem that I think I should do as a box, and we'll get to that one. All right? But first, before we start even factoring, because we're going to do that, but I want to do 2 steps at one time. What do you do if you have a fraction divided by another fraction? That sounds weird, okay? If you remember, if you divide by a fraction, you're going to keep this one, and instead you're going to multiply by the reciprocal of the other. So if this stays the same, this changes to multiplication, this guy just flips. Right? I'm going to talk about that as we go on. Alright? I don't have the equal sign here, but just to make things easy, I like it systematic. I'm going to go down here, and then I'll come back up here if I have to. Alright? So, I'm just going to factor all these. But once I start factoring this, I'm going to remember, hey, this becomes multiplication, and this is going to flip. Alright? So, this is a different square. It's the easiest thing that you can factor. X plus 2, x minus 2. Easy. That one didn't even require a box. Now some of you on the next one, you're like, Mr. Charanza, I'm going to need to use a box. Go for it. Or whatever method of factoring you need to do, but this is factorable. And when you do factor, you end up getting 2x minus 1 times x minus 2. Now right off the bat you're saying, hey, something could cancel, I can see it. Well, let's just do everything and then we'll keep going, then we'll start canceling. I don't want to do everything at once. So when you divide this fraction by another one, you're going to actually multiply, so that changes the multiplication, by the reciprocal. So what I'm going to do is I'm going to factor this guy, but since I'm doing the reciprocal, this guy now goes on the bottom. Alright? When you factor this with a box, if that's how you want to do it, you're going to get 2x plus 1, x minus 2. Alright? And now the factor of this guy, you're going to bring it now to the top because he's on bottom. It's a reciprocal. This is the difference of squares. 2x plus 1 times 2x minus 1. That one didn't even require a box. Now let's look and see if we can cancel anything out. Now, the thing that you need to remember is, because this is multiplication, all of this stuff is multiplied together and all the bottom is together. So it's like all of this is on top and all of this is on bottom. Heck, if it makes you feel better, you could do it like this. They're all one thing now, because you multiplied them together, okay? That's how you multiply fractions. Multiply the tops, bam. Multiply the bottoms, bam. Now, look to see if you have something the same on top as you do on bottom, and that's when you can cancel. You're reducing, okay? You can reduce factors. That's the thing. You can reduce factors when you have fractions, okay? So, this is a factor in the parentheses, and that's another factor. Do you see an x plus 2 anywhere on the bottom? No. But I do see, that's one of the first things people might have saw when I just did this guy, you have an x minus 2. They cancel. So I'm starting to reduce. Alright, so nothing there. X plus, or 2x plus 1. Do I have another 2x plus 1 on bottom? Right here. They cancel each other because they're factors. The whole thing is a factor. The thing's in parentheses. 2x minus 1. Do I have a 2x minus 1 here? Right there. So he's going to cancel out with that guy. Now the thing you need to ask yourself is, what the heck do I have left? Because that's important. And it's where they're located also is important. I have a x plus 2 on top in the numerator. I have a x minus 2 on the bottom, the denominator. So this guy technically is equal to this, right? But since we reduced, this is also equal to x plus 2 over x minus 2. And what I want y'all to do is, when you have a free response question on quiz, test, even homework, box it. So I know, don't make me look for it, right? It's right here. Now, some people might say, well, Mr. Charanza, look, the 2's cancel and the x's cancel. No, they don't. X is not a factor on top. You're adding it to 2. You're not multiplying it to 2. Same thing down here. If it was 2x and 2x, then sure, the x's cancel and the 2's cancel. But you have a plus sign and a minus sign. X is not a factor on top. A 2 is not a factor. Together, they're 1 as a factor. Together, they're a factor. And that's what we had left over, so we're done. We can't do any more. All right? So that was a pretty good one. A little involved. You had to remember to multiply by the reciprocal because you were dividing. And then you also had to look for things to cancel so you can reduce. In other words, all of this stuff is just that. And that's the cool thing about math. Alright? Let's go to number 2. Alright guys, now what we're going to do is number 2. Now number 2 looks a little more daunting because now you have 3 expressions. But now you're not multiplying or dividing, you're adding or subtracting. Now we got to think about this. When you multiply, like on the previous one, you can just multiply across, multiply on the bottom. It's different with adding and subtracting. We talked about that at that little pre-notes that I was talking about, where if you're adding fractions, you're going to have to find a least common denominator. And right now it looks confusing and you're like, I don't know what it is. Alright? And I realized I just made a mistake. Boop. That's supposed to be minus sign. Alright. So here we go. This is what we got. 3x over 2x minus y minus 2x over 2x plus y plus 2y squared divided by 4x squared minus y squared. First glance you might not think there's any common denominator, but this guy is very factorable. Alright? I'm going to write this kind of small. Alright? And actually what I recommend y'all doing, this is what you have on your paper. Everything else you write, write small, because this is actually a doozy. It takes a little bit of effort and a lot of room. All right. So just so we know, because I'm going to rewrite this later bigger. This can be a difference of squares. This can be factored as a 2x plus y, 2x minus y. This right there is it could be written in factored form as 2x plus y and then times 2x minus y. Well, hey, there you go. There's a 2x plus y, there's a 2x minus y. I think we're good now. Now we know what the least common denominator is. And as before, when you had a least common denominator and it happened to be one of the other denominators, we're not going to do anything to this. We'll leave it in factored form, right? But these are the things that are missing something, all right? So I'm going to write down here, like I've always been doing, is once I'm done, I might come up here, all right? I might have to write a little, I might have to cram it in over here, but you'll be able to see it. I'll do my best. All right, so what we're doing is simplifying. We're not solving, we're simplifying. Well, what is 3x divided by 2x minus y missing? Well, this has a 2x minus y. It doesn't have the 2x plus y. All right, so I'm going to rewrite. I'm doing this on purpose. All right, I'm going to rewrite this first. 3x divided by 2x minus y. I said I'm missing a 2x plus y. As we said before, if you're going to find a least common denominator and make everything have the common denominator so you can add them or subtract them together, you gotta, what you do to the bottom, you gotta do the top. You have to multiply by that fancy 1. This is where you have to be very careful. Especially when one of your factors for your least common denominator, or in this case both of them, are factors. You better put parentheses around this stuff. That's an expression. It's a binomial, or not. I mean, it's a binomial or bigger. All right. So you got to put parentheses around it, because what happens when you multiply this 3x to this guy? Distributes to the 2x and the plus y. Got to be aware of that. All right. This guy is also missing a part of the factors to get the least common denominator. Right, so I gotta put this minus sign here. 2x divided by 2x plus y. This one's missing the 2x minus y. But what you do to the bottom, you gotta do the top. And I said, please, please, please use parentheses around your binomials or bigger, your polynomials. Something bigger than just one term. This is a monomial. But anything that's a polynomial, so 2 terms or bigger as a factor, you better put parentheses, because you're going to have to be doing some distributing. All right. Don't forget, last but not least, this guy. We don't have to do anything to him. Plus 2y squared divided by 4x squared minus y squared. All right. Now what can you do? Here's what I'm going to tell you not to do. And actually I just made a mistake. I made a mistake because I don't want you to leave it like this. We already factored it. Let's write this in factored form. All right. 2x plus y. And then 2x minus y. All right. Don't multiply your denominators together, because something could cancel. All right. Now the tops you do. You're gonna simplify this top, this one, and then you're gonna subtract and add them, and then we're gonna see what we can do. All right. But leave these in factored form, because I said if I'm asking you to simplify rational expressions like these guys, something's gonna cancel. All right. So leave factors out there available for us to look at to see if we can cancel. So everything is going to have a denominator of 2x plus y. My thing is, let's just get going. Let's just understand, okay, that you're going to have, once we subtract and add this together, you're going to get a 2x plus y over 2x minus 1. Okay? But let's talk about this part first, this guy. In order to multiply them together, you're going to have to distribute this positive 3x. So what's a positive 3x times 2x? Well, duh, right? 6x squared. What's a positive 3x times a positive y? It's a positive or plus 3xy. Here comes the tricky part. Don't think of this just as a 2x. There's that minus sign. We're going to treat it as a negative when we distribute. Okay? What's a negative 2x times a positive 2x? It's a negative 4x squared. What's a negative 2x times a negative y? That's a positive 2xy. And lastly, alright, so we multiplied these together. I distributed it to here, distributed it to there, right? This guy, I have nothing to distribute. He is what he is. He has this denominator that we want. So we're just going to tack him on. Plus 2y squared. Alright. Looks even worse than before. Not as bad as you think. I like to look for and identify common or like terms. Hey, there's some x squareds. There's a y squared, but he ain't an x squared. Right. Here's some xy's. Got a plus 3xy, got a plus 2xy. And then we got our lonely 2y squared. So let's combine these like terms, okay? And then go from there. All right? Now what I'm going to do is pause this, all right? And I'm going to raise this up, and so you can see it. All right, you have all this written down. I'm just going to raise it up and keep going because I ran out of room. I'm not going to try to squeeze it in over there. All right, so what we got now is all this. I said I'm going to combine, so I'm going to do that first. Once I have it combined, I'm going to erase it for you. All right, what is 6x squared minus 4x squared? That's 2x squared. All right, 3xy plus 2xy. It's 5xy. And then lastly, you have this guy all by himself. There's nothing to combine with. So you're just going to tack it onto the end plus 2y squared. All right. So now we kind of made it a little bit easier to look at. That's just the numerator though. Got to put the denominator there. This guy hadn't changed. And I said leave him as factors because we're hoping something's going to cancel. 2x plus y, 2x minus y. And looking here, you're like, Ms. Charanza, it doesn't cancel. Right? This is where I say, I will show you a box method to factor this because I think this is a little bit trickier than just basic, just x. Here we have x and y. All right, let me erase this. Remember how we box. All right, I'm going to do this guy. Heck, I'm going to do them all the way over here so hopefully I can see. All right. All right, we have this first term. You have a 2x squared. Then you have a 2y squared. So we need a product and a sum. All right. Well, the sum is always this guy, the guy in the middle, the positive 5xy. The product then, so that's a sum. The product is when you multiply these two corners. 2 times 2 is 4. X squared times y squared is x squared y squared. Now think to yourself, what two factors of 4x squared y squared will add to 5xy? Well, you know the sum is going to be xy, so let's not even worry about the xy. When you multiply them, you'll get x squared y squared. When you add this, whatever it is, you'll have an xy. But the number, the 4 and the 5, what factors of 4, when you add them, will give you 5? What about 1 and 4? 4 times 1 is 4. 4 plus 1 is 5. There we go. Now this is where still people get a little confused, right? Factor. What do these have in common? Look at the numbers first. You got a 2 in common. You got an x in common. Just a y there, no y there, so we don't have a y. Here we have a 1. It's a positive 1. And then just a y. Here you have just a 1 in common, and then also an x. And then you have a positive 2 in common with the numbers, and only as for the variables, you only have a y. There are your factors to the numerator. Alright? So this guy, I'm just going to use the stuff in blue. I'm not going to use the 1s in front of the y and the x, that just looks weird. But what you have is, you have a 2x plus y, alright, times this other factor, x plus 2y, alright, divided by, this guy's still there, so these are equal. I just rewriting this as factors. 2x plus y, 2x minus y. Our goal here is to see if anything cancels. Well, does anything cancel? Well, mine, that doesn't minus, okay. Hey, 2x plus y, 2x plus y. How about that? So what's our answer? What's the only thing that's left? You got an x plus 2y divided by 2x minus y. You can't do anything else with that. That is it. Number 2 is done. That is the reduced form of all that stuff. In other words, we just simplified. All right? The good thing is, this is a video. Rewind. Look at stuff that we've talked about here, okay? See if there's anything that you don't understand. Go back and see. Once again, text me on Remind. You can talk to me at school if something did not make sense, all right? But write these down. Regardless if you're struggling to understand, write it down. And when I look at it, we can talk about it on your page. The scary number 3. All right, we're still simplifying. Now this scares people because you have a fractions, within a big fraction. Not a big deal. I do want to recap one more thing. We're right over here on this side. All right. We did talk about fractions, but if I asked you, all right, I had 2/3, and I said multiply that by 5. A lot of us would take this 5 and multiply it to the 2 and to the 3. Incorrect. How do you multiply fractions? Well, you got to make sure both of them are fractions. That's a fraction. Well, 5 is not a fraction written like that. How do you make it a fraction? It's 5 over 1. And now how do you multiply them? 2 times 5 is 10. 3 times 1 is 3. Remember that, because that's going to be a big deal here when we talk about simplifying number 3. Alright? So let's look here. Even though these are fractions, when we look to simplify these situations, alright, you'll notice there's a pattern to every type of situation given. Right? Number 1 was different from number 2 in a sense. Number 2 is different than number 3 in a sense. Alright? But what did we do in number 2? We found the least common denominator. This is what we're going to do here as well. Not really necessarily the way you would think, okay? Or maybe initially. But it's going to help us to knock out those denominators. So now you won't have a fraction within a fraction. So it won't be so scary to look at. Alright? So instead of looking at this and this, I'm going to look at the entire thing. Alright? I'm not going to look at this part separately than that part. The whole entire thing. Look at the denominators, x and x. What's the least common denominator that you look at here in the numerator and the denominator? Right? X. So how can I knock out that x? Right? Well, I'm going to multiply this big fraction. I'm going to multiply top and bottom by x. Got to do top and bottom. Okay? Now, we're going to have to multiply this to all this. Now, what do you notice about the top and the bottom? They are polynomials. More specifically, a binomial. What did I say? You better put parentheses around those suckers. Okay? So what are we going to do? We're going to distribute this factor into that. So let's do this. What is x times x? That's easy. X squared. Now this is where it gets people. Well, Mr. Charanza, what's up? Well, when you multiply x times 1 over x, you're going to multiply to the 1 and the x, correct? Wrong. What you're going to do is, remember I said, just like over here, that whole number is technically over 1. Alright? So what's x times 1? X. Don't forget that minus sign. What's 1 times x? Now we're multiplying the denominators. 1 times x. Now this can reduce, and we're going to do that later. That's the whole point. Alright? You know what? Let's just do it for the heck of it. Watch this. So we haven't done anything here. But what happens here? X squared minus, what's x divided by x? 1. So what happens when you say x divided by 1 over x? Goes to 1. Alright? So let's try it again. We gotta do the other one. Gotta multiply the x times the 1 and the x times 1 over x. Well, x times 1, x. Alright? We could do it the old school way, like up here. We could say this is over 1. X times x. Alright, x times 1 is, don't forget that minus sign. X times 1 is x. 1 times x is x. That reduces to 1, or x times 1 over x is 1. Now this doesn't reduce yet. I told you something's going to have to cancel. Nothing's canceled yet. Alright? But look what happened. We took this crazy looking thing right here, and now you don't have any numerators within, or fractions within fractions. Alright? You don't have any fractions in the numerator, you don't have any fractions in the denominator. That's the difference of squares right there. That's factorable. Alright? So I like to come back over here, just to make myself neat. X squared minus 1. That's x plus 1, x minus 1. Difference of squares. Divided by x minus 1. Don't forget all that stuff in the denominator. Worked really hard for that. Now look and ask yourself, is there anything that could cancel? Sure. X minus 1, x minus 1. So what's your answer? What are you left with? Just this guy. Alright? There's nothing left in the denominator. Okay? So, x plus 1. Alright? If there's nothing left, yeah, there's technically over 1, but why bother doing that? We're big kids, we don't have to do that. This right here actually simplifies to that. That's pretty cool. Looks neater. Alright? So that right there is it for simplifying. What we're about to do now is to solve equations. I'll show you the difference. Alright guys, let's look at number 4. This is different than 1, 2, and 3 because, well, looking at the directions, it says solve the following equations for x. You know it's an equation because you have an equal sign. Equation, equal, okay? And your goal here is to actually solve for x. What number does x have to be in order for this statement to be true? Another way to put it, what number can I plug into this expression that's going to give me 0? This is a quadratic. You need to think about what quadratics, cubics, linear functions, all these different functions, what are the possibilities or how many possibilities could I get? Well, for a quadratic, the exponent right here, the 2, kind of gives it away. There's a possibility you can get 2 answers. All right? And the way to do that, when we solve for quadratic equations, we need to set equal to 0. For actually any polynomial, you set equal to 0. It already did this for us. We're good. What I would recommend you doing here then to solve is box method. Once again, I ain't gonna do it. If you have questions, ask me about it later. Alright? Box method, easy. Alright? I'm a more guess and check. Alright? So box method, you have your method. It is really nice and it gets you the right answer every time if you have it set up correctly. Alright? Me, I'm a guess and check kind of guy. Alright? So, like, sometimes I think to myself, what could I multiply to get 5x squared? Alright? Well, probably it's going to have to be a 5 and an x. Alright? So 5x times x is 5x squared. Hey, that works. Now, then you also have to think about, what are the factors of 2? Well, that's not hard either. Actually, negative 2. You either have a negative 2 and a positive 1, or a negative 2 and a positive 1, right? Or vice versa. Right? So, let's think about this. I could put a 1 and a 2 here. I could put a negative 1 here and a negative 1 here. A positive 2, positive 2. All right? Or I could put a negative 2 or a negative 2, and then a positive and positive, depending, right? It's a lot of different scenarios. But so you're like, well, you have 4 choices. All right, what are you going to do? It all comes down to this guy. All right? I'm going to choose a +1 here and a -2 here. What happens when you multiply negative 2 and a positive 1? Negative 2. That works out. But why does it work out? Why couldn't I have done positive 2 and a negative 1? Well, all because of positive 3x. 5x times 1 is a positive 5x. Negative 2 times x is a negative 2x. What happens when you say 5x minus 2x? 3x. That's my way of doing it. That's the way I was taught. Some people are like, Mr. Charanza, I'd rather just, I'm going to box this. I'm going to fast forward right now. That's fine. Alright? I'm a guess and check guy. Alright? I'm a guess and check guy. So this is what you get. Now to solve, once you have each factor, alright, the rule from Algebra 1 and Algebra 2 is each factor could be equal to 0. So that's what we're going to do. We're going to set this one and see what x needs to be in order for this to equal 0. And then I'm going to say x plus 1 is equal to 0, and then I'm going to solve for x to see what it needs to be for this situation. Alright? I use different colors. Right. So how are we going to solve? Alright, you're going to add 2 to both sides. Alright. You're left with 5x is equal to 0 plus 2 is positive 2. I'm going to now get the x by itself by dividing 5 to both sides, because when you solve, you always do the inverse operation. It was minus, so I added. I'm multiplying, so I'm going to divide to get rid of it. X is equal to 2/5. Alright, I wrote it small. I'm going to write it bigger later because there's actually going to be 2 answers. Well, how do you get rid of the 1 here? Inverse operation. I'm adding 1 to get rid of it. I'm going to subtract 1. So x is equal to 0 minus 1, well, negative 1. So I don't want you to leave your answer separate. And what I've been doing this whole time is put it in a spot and boxing it. That's what I want you to do here. All right? 2/5 and 1. Those are the solutions for this equation. X can equal 2/5 to get equal to 0. X could also be negative 1. Right? I'm not going to be nitpicky on how you present your answers. What I mean is in terms of numeric order. I personally like it in numeric order because it looks neat. That's just how it was taught in college and in high school. So negative 1 is the smaller number, so negative 1, comma, 2/5. So you have two answers, -1 and 2/5. Don't put parentheses around it. This is not an ordered pair. X is equal to -1 or X can be equal to 2/5. Done. So number 4, not so bad. More fractions. Okay, first thought, common denominator, go. Hold your horses, we're not simplifying. There's an equal sign, and the instructions before it says solve for X. All right? Well, let's think of it this way instead. All right? This is a fraction, this is another fraction. Well, this fraction is equal to this fraction. We're asking, what does X need to be in order for this statement to be true? What does X need to be in order for this to equal this? All right? That's what we call a proportion when we say a fraction is equal to another fraction. Think back to 8th grade, 9th grade. When you solved, even last year in Algebra II, how did you solve proportions? The very step, the simple steps to do is cross multiply and divide. Now before you start cross multiplying, what do I notice about some of these numerators and denominators? They are binomials. You better put parentheses around it because you're about to multiply. Because what did I say you have to do? I said you're going to cross multiply. I'm not saying multiply across, I'm saying cross multiply makes a X, makes a cross. This times this. Alright. X minus 3. I know the greens are hard to see. X minus 3 times X minus 2 is equal to this cross product. Because if there are proportions, cross products are equal. Alright, that's why we're doing this. I'm not just doing it because it's magic. The definition of a proportion is if these are proportional, this is equal to this, then the cross product should equal. Alright, X times X minus 4. I don't want to use green anymore right now because I know it's hard to see. So what are you going to do? You're going to have to multiply this together, simplify, multiply this together, and simplify. And then from there, we're going to solve for X. Seems a little crazy, but if you remember just going step by step, don't try to see all the work before you even write it down. It's going to drive you nuts, it's going to stress you out, and you're going to panic. Don't do that. I cross multiply because that's what I'm supposed to do when I have proportions. Cross multiply. Alright? Well, how do I multiply these together? You're going to probably, most of us would prefer to do the box. Alright? In other words, multiplication using the box. So not factoring, but you're multiplying. Me, I'm a different kind of guy. Right? I was taught differently. Alright? It's kind of like, it's a backwards version of the one I showed you when I factored on the previous problem. Well, what's X times X? Alright? X squared. What's -3 times -2? +6. Alright? And then, so I multiplied the x's together, the front two terms and the back two terms. Front two terms with this, back two terms with this. But then also, x times -2 is a -2. And then -3 times x is a -3x. Oops, -2x. What does that equal when you add them together? -2x plus 3x. That's what you would be doing if you did the box. You would have to add -2x and -3x. Alright? It's -5x. Alright? Or just box. Alright? I probably just wasted people's time again. Alright. This is what you get here. So that's simplified. Equals. Now this one, you don't have to use box. This one's simple because this is a monomial times some polynomial. And I just distribute that sucker in. You get x squared, x times x, minus x times 4, 4x. Alright, now it looks like, hey Mr. Charanza, I see x squareds. We gotta set this equal to 0. Maybe. That's a good mindset to begin with for sure. Alright? But let's just move some around, alright? Let's move this x squared with this x squared, alright? So it's a positive x squared. How are you gonna move it over? Alright? you're going to want to subtract it. What's x squared minus x squared? Goes away. This no longer is a quadratic equation. You only have an x. So this is actually a linear equation that you're trying to solve for x. So we don't have to set it equal to 0, right? I'm actually going to get all the x's on one side and anything without an x on the other side. Well, there's a plus 6 here, but then there's this negative 5x here. I'm going to go bring them over here with this negative 4x. In order to do that, inverse operation. I have to add 5x to both sides. That'll cancel. But what you do to one side of the equation, you got to do the other. So I added 5x here. I'm going to add 5x there. I'm left with 6, positive 6, is equal to negative 4x plus 5x. 1x. Or we would just say x. And that is number 5. Alright? Take some time. That's why you get to rewind and look and see. See what you can do. Alright? Good one. Alright guys, number 6. This is even harder. Alright? It looks more difficult, but I promise it's not that bad. Alright? Work step by step. Well, know you're solving. You have an equal sign, and the instructions say you're solving for x. What does x need to be for this statement to be true? Alright? Well, the first thing I notice, alright, x minus 10, x minus 2, and you have this trinomial, x squared minus 12x plus 20. Well, I'm gonna show you a trick here, alright? This usually just works better for everybody. This is the personal way that I like to show people how to do it. Well, not really, I'm going to be completely honest, but it gets the point across, people will understand it, and they get the answer, and that right now is what I want us to understand, okay? I feel guilty saying that, but, you know, I think most of us are like, hey, let's just show me how to get the answer, Mr. Charanza, right? But what I want you to understand, though, is this only works for these type of problems, alright? The reason I know to use this is because I know how to do it different ways, and it always works out that I can do this trick, okay? Alright? Well, I'm going to look for a least common denominator, alright? That means I'm going to have to factor that guy, box it, alright? Box that sucker. And when you do that, I'm going to write it really small right here. And then, well, you know what? I'm just going to write it. I'm going to start going after it. I'm going to write it big. When you factor this, right, you're going to get x minus 10, x minus 2. Now, why do those look familiar? That's a good thing. Alright? But we want to find a least common denominator. Alright? Well, it ain't this one, ain't this one. It's both of them together. Okay? So what we're going to do now, alright, is I'm going to do this on purpose. Leave these big gaps that I'm about to do, okay? I'm going to have to write over here a little bit. I'm going to have 2 minus x minus 10. I'm going to leave a big gap here, right? Minus 3 over x minus 2. All right. Same thing. I just put gaps here for a reason, right? What I'm going to do, because this is an algebraic process, is I'm going to get rid of this x plus 10 and x minus 2. Well, couldn't I multiply the numerator? Just the numerator by x minus 10. Because technically, if you want to be more specific, you know, it's over 1. Okay? So, what happens? The x minus 10s cancel, the x minus 2s cancel. But you know, algebraically, I can't just do that. But what we can do is, what you do to one side of an equation, this is algebra, what you do to one side of the equation, If you're going to do it, you've got to do it to every part on the other side of the equation. What you do to one side, you got to do it to the other. To every term on the other side. All right? This will help us cancel stuff out, but I got to do it to the other side. Meaning, I got to say x minus 10 times x minus 2. If you want to put over 1, put over 1. Right? Just understanding that you're only multiplying the numerators together. Right? And then you got to do it to this guy too, because this is another term. If you want to put over 1, that's fine. Right. So not only now do these cancel, so nice, because x minus 10 cancels out with x minus 10. X minus 2 cancels out with x minus 2. Well, here, not everything cancels. X minus 2 does cancel out with this x minus 2. That's a good thing. X minus 10 cancels out with that x minus 10. So, now that we're solving, the cool thing is we no longer have denominators. Still gotta solve and just kind of move stuff around, but it's not as bad. So I'm not gonna do 2 steps at one here because that's gonna get confusing. What am I left with? I canceled out the x minus 10 on this part. I'm left with the 2 times x minus 2. Use parentheses. Minus. Alright, I got this minus 3 times, the only thing that's left over, x minus 10. That's it on this side of the equation. What I'm left with on the right side, just the 6. Just that lonely 6. Alright, we gotta solve. That means I'm gonna have to do a little bit more work. Gonna have to distribute this 2, and then I'm gonna have to distribute this minus 3. Since I'm gonna distribute it, I'm gonna say it's a negative 3. Alright. And I'll get 2x minus 4 minus 3x plus 30 is equal to 6. Right? I just multiplied the 2 in, so that's how I got the 2x minus 4. I distributed in the negative 3, that's how I got the negative 3x plus 30. Negative times a negative is a positive. Alright, and nothing happened on the right side, so I'm good. Well, when you solve from Algebra 1, identify, then combine like terms. So I have stuff with x's, then I just have some plain old numbers. I can't do anything with this 6 on this side. It has a barrier, alright? You can't cross over, you can't start combining stuff on the other side of the equal sign. So we're only dealing with the left-hand side. The 6 is all by itself, I can't simplify. It's a 6. Right? So I'm left with 2x minus 3x. It's a negative x. Negative 1x, right? But I'm going to call it a negative x. And then plus, negative 4 plus 30 is a positive 26. And this is equal to 6. Right? There's a lot of different ways people like to do this. I like to do it this way. A lot of people like to move this x over. I'm like, I'll deal with him later. I know it's negative, but I'll deal with him later. I'm going to subtract 26 to both sides of the equation. Right? A lot of people like to make that bar once you start solving. Right? That's going to cancel this out. So what am I left with? I did it. We're in another room. I'm going to come over here. I always tend to do this. Got to kind of block it off from all this other stuff. Alright, so when I do this, I will get a negative x, because that's what's left over, is equal to positive 6 minus 26. That's a negative 20. But I'm not looking for what negative x is. I'm asking you what x is. Alright? There is a mathematical way, and I'll explain in just a sec. But my thing is, if I want to change this to a positive, algebra says, if I'm going to change this sign, I'm going to change this sign on the other side. Technically, how did I do that though? This is the correct answer. How did I actually do that? There's a -1 here. How do I get rid of it? Divide it out. I'm left with an x. But what you do to one side of your equation, you got to do the other. It cancels out that negative as well. That's why you get a positive x is equal to a positive 20. That is probably one of the hardest ones to solve. Now guys, I guarantee you, when you get to your notes, and look at your notes and compare it to your homework, you're going to be like, well, this is harder, or this isn't exactly like we've seen. Well, of course it's not. It's not going to be the same problems over and over again. It's the same style. You might have to think a little bit harder, a little bit differently, but it's doable. And we will have time in class to talk about it. This is what you're going to do at home. Write down your notes. You come to school the following day, and we will talk about it. You will work together and do the homework, and that's a perfect time to ask questions, okay? But we're not done yet. We have 2 more problems, and we're done, all right? Number 7. This is a tricky one, in the sense that it can be easily solved in 2 different ways, which gives you 2 different looking answers, but actually they're the same thing. It's just you would have to simplify the answer a bit to get it. All right. Now the one thing you notice that's different than the previous solving equation ones is that you're solving for a variable, but you don't just have one variable. You have multiple variables. Right, you have an S, you have an R, you have an H, you even have a pi. Right? It says here to solve the equation for H. When you say solve, that means just get that variable that you're solving for by itself. I'm going to show you 2 different ways to do this, because I think it's very helpful that you understand that there are multiple ways to do a problem, even though your answers might look a little differently. I know both possible and the forms of each answer, but they're both right. They're not different answers, they're just different forms. Alright, so one way. Way number 1. Alright. I'm going to, well, I'm solving for H, so I kind of like to just identify him. There he is. I'm solving for H. So, here's all this jazz. I'm going to take, and I'm going to move it over to this side, because I don't need it by H. I'm trying to get H by itself. Right here, it's cluttering up all this stuff. So I'm going to do the inverse operation, minus 2 pi r squared to both sides. Minus 2 pi r squared to both sides. Alright, so this is number 1. Alright, well, S minus 2 pi r squared, you can't combine those. Alright, they're different, they're not the same thing. So we are going to just say this is S minus 2 pi r squared, which is equal to the rest of this jazz. 2 pi r, what am I solving for? H. What's happening to H? All right. At first I had this stuff added to this expression right here, or this term I should say, that had H in it. All right. It was added to it, so to get rid of it, I subtracted it. Now I have all this other stuff that's part of this term, H is part of it, and they're multiplied to H. How do you get rid of all that stuff? Well, the inverse operation for multiplication to get rid of that stuff, simply to divide. 2 pi r. What you do to one side, you do to the entire other side. There's 2 ways to do this. You can do each term divided by 2 pi r, which gets kind of messy, or for all I care, the entire side divided by 2 pi r. Okay. So I like to use blue. So what is H now equal to? S minus 2 pi r squared divided by 2 pi r. Mr. Grades, I thought you had another version. I'm going to do it right now. S is equal to 2 pi H plus 2 pi r squared. Oh, here, wait. No, this is a fancy way of doing it. I like this way because it just it notices common factors and you factor it out, and actually it doesn't look that hard, right? After you factor stuff out. Well, I notice here, in other words, if I can ever factor, I'm going to do it, right? See what happens. Sometimes it helps, sometimes it might not. In this case, it helps go a little faster, I think. I have a 2, I have a pi, and an r, and I'm trying to solve for h. Well, here on this term, there's 2 terms, 2 pi and r, and technically another r because it's being squared. So I have 2 pi r, 2 pi r. I can factor that out. What happens when you factor? Technically, you're dividing it out, right? So I'm not doing anything with this s. Right? 2 pi r is what I'm taking out. So when I divide 2 pi r on this side, what am I left with? Or this term, I should say. When I divide out 2 pi r from this term, I'm just left with h. Plus, all right? When I divide out 2 pi r from this term, there is that extra r, so what I'm left with is just another r. All right? How do you get rid of this now? How do you get rid of this stuff that's right here by this h? It's being multiplied. I'll divide. I'm going to divide 2 pi r to both sides of the equation. All right? Goes away. What am I left with? S divided by 2 pi r is equal to, what's the only thing that's left? The h plus the r. I dropped the parentheses because it's not being multiplied by anything anymore. I canceled it out, so I don't need the parentheses. Now the only thing I have left to get rid of, so the h is by itself, is the r. So I'll subtract it to both sides. Should use a different color. Oh. Now let me ask you this. S divided by 2 pi r minus r. Is S divided by 2 pi r and r, are they like terms? No, they're not. So the answer for this one looks different than the previous one, but they're actually the same. Even though they look different, they're the same. Tell you what, it's actually not that hard, but someone comes to school and shows me how these two are equal, I'll give them 5 extra points on their first quiz. How about that? Just on a separate sheet of paper, write this down, make it look like that. Show me the work. It's not that hard. It's pretty easy. Alright, for this problem it says, find the equation of a line that goes through the points -3, -5, and 4, 6. Well, I'm going to be honest, besides last year, we're not going to use that one. We're not going to use standard form. But what we will use, slope-intercept, and my personal favorite, point-slope. Alright? M and M, we know that to be slope. B, alright, for this one is a y-intercept. And then the x1, y1, actually that's just an ordered pair, that's a point. Alright? That this graph, the line, goes through. Alright? So let me show you something. It might take a little bit of time because I want to show you multiple ways. Alright? The first way, the first thing I'm going to do is good for everything. Let's find slope. M is equal to y2 minus y1 over x2 minus x1. Now, it doesn't matter which one you call which, but let's just call this one x1, this is y1, x2, this is y2. Okay. Now I'm use black. Alright, so let's find slope. Alright. 6, that's my y2, minus my y1, so I'm going to have to put parentheses so I know I'm minusing a negative, divided by x2, 4, minus a negative 3, so parentheses negative 3. Alright, what do I get here? That's 11, because you're minusing a negative, that's weird. Keep, change, change. Right. And then that same thing here, keep, change, change. What is that? 11 sevenths. That's my slope. That's M. For either one. I said I just want the equation of a line. I didn't say I wanted the equation of a line in standard form. I didn't say I wanted the equation of a line in slope-intercept form. I didn't say I wanted it in point slope or y-intercept or whatever again. And actually, I don't care which one you do. I'm going to do the easy one. Alright. Y is equal, not y is equal to, but y minus, it actually doesn't matter which one I call y1. I'm going to say this is y1. So minus a negative 5, that sounds weird, plus 5 is equal to 11 sevenths. So y minus y1 is equal to m times x minus x1. Well, I'm subtracting a negative 3, so it's actually plus 3. That is a valid equation of a line. I could have very much well done this. Y minus, I could have called this y1. It doesn't matter which one you call x1 and y1, right? Right? So I could have said 6. Y minus 6 is equal to 11 sevenths. Alright? Times x minus x1. Well, that's my new x1. Right, so 4. Those are valid. Well, to be honest, guys, if you would just take either one of these, you would get the right form for that as well. Both of them would get you the same answer. Alright? So some of us might be like, okay, Mr. Cringe, can you just do it for me real quick? Well, then I got some time. Alright? I'm going to choose this one. Alright? I'm going to get it into y is equal to mx plus b. So in order to do that, I'm going to have to distribute, let me use green, 11 sevenths into here. So nothing's happening with the y plus 5 yet. Y plus 5 is equal to 11 sevenths x. Alright? When you distribute it, this is a 3 over 1. So it's a 33 plus 33 over 7 times 1 is 7. Alright? Now I've got to add 5 to both sides, or sorry, subtract 5 to both sides to get y by itself. Well, what am I going to combine this 5 with? Minus 5. It ain't the thing with the x, because those aren't like terms. It's this guy. So this is actually what I have so far. Y is equal to 11 sevenths x plus 33 over 7 minus 5. Oh, geez. I don't have a common denominator. If I multiply top and bottom by 7, though, 5 times 7 is 35. I got it. Y is equal to 11 sevenths x plus, add these together, they have a common denominator now, they're both going to have a denominator of 7. You're going to get 33 minus 35. Well, what is that? 2? More specifically, a negative 2? So we don't add negative 2's. We subtract positive 2 sevenths. And that right there is another valid equation of a line. If you do that one, I ain't doing that one. Right? Which one's easier? It ain't that one. A free response question on a quiz or test? Now, sometimes I might give you a multiple choice question. I would do it this way first. See if it pops up on your answer choices. If not, find it. Whatever. Free response? Easy. Alright? Guys, once again, if you have any questions, you know you can contact me through Remind. You can even email me. That's old school, I know, so you can just do a Remind. Or come in before school. Come in after school. Ask me during class, alright? At appropriate times. I'm here for you always, alright? This unit, okay, is a recap. But I go really hard on this because we're hitting the ground running from last year. There's not getting started real slow. This first assignment is very important. Make sure you understand how to do this stuff. Alright? I'm always here for you. You gotta try. Alright? If you put effort, if you persevere, and you come to school every day with a positive attitude, I promise you will succeed. Find me if you need me. Do your best. Forget the rest. Let's go.